All right, guys, we're going to go over a couple, two more specifically concepts, and you can keep adding to your notes that you were already taking. I just want to make sure you label each kind of section so that when you're looking for something in particular, you have the label. So the label of the concept we're going to learn right now is terminating and repeating decimals. What I like about this math is the words terminating and repeating really help you remember which one's which. You know, sometimes like our improper fraction, it's like, why would you call it improper? That makes it sound like we can't use it, and really we want to use it. It should be called a proper fraction. But these names really help you remember, okay? So I want you to think about terminating decimals. What is something that terminates? It's something that ends, okay? Even the Terminator, he's coming to end you. I'm sorry, I'm not a huge Terminator fan, but definitely if you are, that's going to help you remember it, okay? So terminating, something that ends. And it's exactly what it sounds like. It's a decimal that has an actual ending. Might be kind of far out there, but it ends. It doesn't just keep going on forever. And I want to show you in the calculator what it looks like when it goes on forever. So I already know that pi is not a terminating decimal. So I'm going to put pi in my calculator. Hopefully you can see this. Pi, I'm going to hit equals. See how that number literally goes on all the way to the end of the calculator? That means the number goes on forever. If you wanted to read pi to me, you would literally spend the rest of your life reading pi because it literally goes on forever. And the calculator obviously can't accommodate that. So whenever you see a number in here that goes all the way to the end, know that that is not a terminating decimal. Another example of something that's not a terminating decimal is the square root of 2. So the square root of 2, I'm going to hit equals. See how it goes on forever? Okay, that is not a terminating decimal. All right? So that one's kind of simple. Repeating decimal means that the decimal does go on forever, so it's not terminating, but it has a pattern. So you might see something like 0.121212. Once you see this pattern, you go, oh, it's a repeating decimal, and then here's how you write it. 0.12, you take the part that repeats, and you put a line over it. And when people see this line, they know you mean 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Sometimes you might see them on a test or in the book with like a dot, dot, dot. If you see that, that means it goes on forever. We don't want to use that. We'd rather use this symbol because that is very mathematical, but I want you to be aware if you ever see this, they're trying to tell you this number goes on forever. So hopefully you take these notes because I'm erasing. To tell if your number is repeating or terminating or any of these things, you have to do the division. And I know that we kind of forget how to do that, so I want to take a second to remind us. So we're going to work with a 13 over 33. Because it's in a fraction form, I don't know if it's terminating or repeating right now. So I have to do the division. And jumping to a calculator is not the way I want you to practice this, because on a math test, they would not let you use a calculator on this type of problem. Okay? They would make you do the math the long way. So we're going to get old school with it, and we're going to divide. And I'm going to remind you how to do that as I go. Okay? So first, remember your 13 goes under. I always have a lot of students ask that. Remember your 13 is also the first number in your calculator. That's really important. And the 33 goes on the outside. And then I already know 33 is not going to go into 13, so I'm going to have to add some zeros here. So the first thing we're going to be working with is putting a 33 into 130. Because I added this decimal, I'm going to add one up here. And I'm going to put my first answer at the end of the 130, right here, above the end of it, and keep everything lined up. So I'm going to try 33 times 4 first. 4 times 3 is 12. 4 times 3 is 12. 13. Oh my gosh, I was so close. But that means I got to go back to 3. So 33 times 3 is 9 and 9. Okay, so I put the 3 over the end of the 130. And then I multiply. 3 times 33 is 99. And now I'm ready to do some subtraction. Okay, so I'm going to borrow. 10 minus 9 is 1. I need to borrow again. 9, 10, 11, 12. So 31. Now, this is when we bring down a 0. And now we're putting this into 310. So let's try 33 times, let's try 10. Now, for those of you that are quick with your math, you already know this is 330. For those of you like me, I need to kind of work it out sometimes because I get really focused on the problem and I forget some of my math common sense, and that's okay. So 0, 3, 3. Too big. Let's try 9. 33 times 9. 9 times 3 is 7, 27. 9 times 3 is 27, 28, 29. 297. That's as close as I'm going to get. So I add a 9. And then I go 297 and I subtract. So I need to carry 7, 8, 9, 10. 2, 9, 10. And I bring down the 0. What do you notice? Okay, you can keep going with this problem. And I'm telling you right now, you're going to get 3, 9, 3, 9, 3, 9, 3, 9. And the reason I know that right now and I don't have to go any further is not because I just know what the answer is, because I do, but because I see this 130 and I see this 130. That means all of this math is about to be repeated. Once I notice that, I'm done. I know my answer is 0.39393939, so I stop and I write 0.39 and I put my repeating decimal symbol over it and I am done. And just to prove it to you, I want to show you on the calculator. So if I do, this is hard to do, 13 divided by 33. Okay, that's not what I wanted. Try that again. 13 divided by 33. Okay, so see it? And I hit equals. There's our number, and it goes on forever. Okay, so it's not terminating, but it is repeating because it has a pattern. All right, and anything you do, you can always check in the calculator, but I really want you in this section to practice your long division because we forget it. We just kind of forget what to do, and it would be a good time to remember. So if for some reason you are not allowed to use a calculator, you're not going to panic, okay? All right, I have one more thing to show you before this video is over. I think it's pretty easy, but let's make sure that we add this word or words to our math notebooks. So additive inverse. Okay, so what an additive inverse is it's really just the opposite of the number. So 3 and -3 are additive inverse and opposite because when I add them, additive inverse, I get 0. Simple as that. Hopefully this makes sense. I am going to have you watch a couple other videos that I made for the 6th graders because it's just going to be a little bit of a review, and then you can get the work done. And if you have any questions, please email me. All right, see you guys soon.